Hello and welcome back to another video, guys. Today we're going to be taking a look at a part of dynamics, specifically finding the normal force on, blocks on, flat surfaces. So one of the most important things about dynamics is the fact that in dynamics, we discussed why things move. So we're going to be dealing with a lot of the forces, basically the things that cause objects to start to accelerate, whether the forces are, moving forces, meaning that they start movement, or whether they're resistive forces such as friction, which would actually slow down objects. What we're going to be looking at today is actually the normal force, and I'm going to start with an example because that's really the best way to understand it. So example number 1, the question says, find the normal force on the blocks shown. Okay, now let's go down. First of all, we do know that the normal force, it's simply a force that the surface the object is placed on exerts to not allow that object to break it. So let's imagine we have like a rectangular box, a square box, and it's placed on like a table. And somebody is basically, there is a force that's upwards, that's pushing this basically upwards by 6 newtons. So far, we don't really have any other information other than the fact that there's a 6 Newton force just pulling this up. We've also been given the fact that this box is about 8 kilograms. Okay. The first thing that I'm going to go ahead and do is figure out all the forces I have on this box already. This box is 8 kilograms, but I know that there's going to be a weight that is going to be pulling this downwards, and the weight of this box is simply 8 times 10, or 8 times g, which is simply 9.8, but we rounded up to 10, so it's about 80 newtons. The normal force is the force that this surface will be exerting it to make sure that the table or whatever doesn't break, so it's going to be upwards. I'm going to show normal force using Fn. Now, I'm going to be taking a sigma F, which means I'm going to be taking a look at the forces that are in opposing directions or in the same directions. Now, right now, Fn and P are in the same direction. So I can say Fn plus P, which was the force that's pulling this object up, plus P is equal to the force that's obviously in an opposing direction to these two. So that's 80 newtons. So I can simply say that the normal force here is simply equal to 80 minus P. And P was actually 6 newtons from the question. So 80 minus 6, the normal force is simply equal to 74 newtons. Now let's go ahead and take a look at another example. Example number B. Let's say the same block was being pulled, but this time the force was at an angle. So the box is 8 kilograms, and it's being pulled at an angle of 45 degrees right here. And again, the force is about 6 newtons. So let's first identify the direction of forces. There's obviously the weight, that's 80 newtons, and that's downwards. Then we have the normal force, that's upwards. However, we have to break down the 6 Newton into its vertex, basically into its x and y components. So the 6 Newton actually has one component in the x direction. That's 6 cosinus of 45. The one that's adjacent to the angle takes cosinus. And another one that's upwards, and that one is 6 sinus of 45 degrees. It is clear that cosinus of 45 degrees right here has no effect on the normal force. And so because of that, we'll only consider the 6 sinus of 45 degrees. Now, let's go ahead and plug in the numbers to see which ones are in the same direction. Obviously, Fn is the same direction as 6 sinus of 45, so they're going to be added. And that's going to be equal to the 18 newtons, which is on the other side, or you can simply think about it as minus 18 newtons. But at the end of the day, it moves to the other side. So the normal force is simply equal to 80 minus 6 sinus of 45 degrees. So the normal force is simply equal to, let's put that in the calculator, 6 sinus of 45 is about 4.24. So 80 minus that would be 75.7 newtons. Now, this is essentially how you find the normal force on a block where the force is being pulled at an angle. Of course, there could be scenarios where you don't have any forces pulling the object. So in the last scenario, let's imagine we have a block of mass, about 8 kilograms, and we're just trying to figure out its normal force. So the weight of this box is about 80 kilograms, which is, the weight of this box is about 80 newtons, so it's 8 times 10, we already established that. The normal force is going to be in an opposing direction to this, and it's working in effect to stop this table, whatever surface, from breaking. So this is also going to be equal to F of n. Now in this scenario, the normal force is simply equal to the weight because there's no other forces pulling this, and as a result, the normal force is simply 80 newtons. Thank you for watching and stay tuned.